Hello, welcome. So today you're going to look at implicit differentiation. Okay, so let's dive in it. So here we are saying that there are some functions that may not be given directly or explicitly. When we talk of explicit functions are of the form y equal to f of x. Okay, so they can be y equal to sine x, y equal to maybe 4x squared plus 3. So example, when I give you equations like xy equal to 1, x squared y minus 3x equal to 2, and etc. Because these equations are in implicit form. Okay. So how are you going to differentiate it? So this is what you're going to be looking at in this lesson. Okay. So we say that in some cases, you can make the dependent variable the subject in finding the derivative. But this approach becomes difficult to work with. So when I give you the equation, maybe x squared y equal to 1, and you have been asked to differentiate this equation, though it is in implicit form, but you can easily make y the subject, which is the dependent variable, which will be 1 over x squared, which can also be written as x is for negative 2. And you can use the power rule to differentiate this function easily. But what if you have been given the equation x equal to y plus sine y to differentiate? You can see that in this equation, you cannot easily make y the subject to find your derivative. So that's why we say that in some equations, you can easily make y the subject and find your derivative. But in some other equations, it might be very difficult. Okay, let's quickly solve some examples. For example 1, you have been given the equation xy equal to 1 to differentiate implicitly. So you can see that here we can easily make y the subject, which will get 1 over x. Okay, and we can write this one as x is for negative 1. And we apply the power rule here, which implies that our r prime of x will be minus 1 x exponent minus 1 minus 1, which will be minus x exponent negative 2. Okay, all right. So example 2, you have to differentiate this equation implicitly. Okay, so you have x cubed y minus 3x equal to 2, and we have to differentiate this equation implicitly. So here there are two approaches that you can go by. So you can choose to make y the subject, which will give you 2 plus 3x all over s cubed, right? Or you do it step by step. So it's like you find the derivative with respect to x of s cubed y minus the derivative with respect to x of 3x equal to derivative with respect to x of what? Of 2. So when you use this approach, you're going to use the quotient rule. Okay, the quotient rule. In this one too, we are using direct format. So you can see that here you have x and y multiplying. So you're going to use the product rule here. And according to the product rule, we hold one of the functions constant. They will differentiate the other one. Okay, and vice versa. So here we hold s cube constant. Then we differentiate y respect to x plus we hold y constant. Then we differentiate s cube with respect to x, which will give us 3x squared. Okay. Minus when you differentiate 3x with respect to x, you're going to get 3. Now 2 is a constant. And we know that whenever you differentiate a constant, you're going to get 0. So it's equal to 0. Okay. So here you're going to get s cubed, the y, the x, plus 3x squared y minus 3, which is equal to 0. So we want to make dy dx the subject. So you're going to get dy dx equal to 3 minus 3x squared y all over x cubed. So this is our final answer for the dy dx. Now, if you use the quotient rule, you're going to get your dy dx to be negative 6 x plus 1 over x cubed. So here the answers are the same. Just that if you want to get the answer for the y prime when you use the quotient rule approach, then you have to substitute this 2 plus 3x over x cubed in place of the y here. Okay, so you're going to get 3 minus 3x squared multiplying 2 plus 3x over x cubed all over x exponent 3. Now, when you break this down, you're going to get this one. Okay, so the answers are the same. Okay, so let's move on to the third question. So we are to differentiate this equation x squared plus y exponent 4, which is equal to 10 implicitly, which is equal to x. So here you're going to get d dx of x squared plus d dx of y exponent 4, which is equal to d dx of 10. Okay, so here when you differentiate x squared, you're going to get 2x plus when you differentiate y exponent 4, you're going to get 4y cubed. Now, because y is a function of x, you're going to multiply this by dy dx, which is equal to 10 is a constant. So whenever you differentiate your constant, you're going to get 0. So here you're going to get 0. Okay. So you're going to get 2x plus 4y cubed dy dx equal to 0. And we have to make dy dx a subject. You're going to get dy dx to be minus 2x over 4y cubed, which is going to give us minus x over 2y cubed. Okay. So the fourth question, we have to differentiate x is equal to y plus sine y implicitly, which is equal to x. So same here, you're going to get d dx of x, which is equal to d dx of y plus d dx of sine y. Okay. So here, when you differentiate x with respect to x, you're going to get 1 equal to dy dx plus. Now, if you are given a function, say y equal to sine of f of x, okay, to differentiate. This is the composite function. So what we do is for you to get a y prime of x, we first differentiate the inner function, which will be f prime of x, okay. Then after that, we differentiate the outer function. So when you differentiate sine, you get cos, right? So you get cos of what? F of x. And this, we use the chain rule since it's a composite function, okay. So same here, we are differentiating sine y with respect to x. So first of all, we will differentiate this y here with respect to x. So you're going to get dy dx. Then we differentiate sine, right, which will give us cos. Then our y. Hope you get it. Okay. So you have to make dy dx a subject. So we are going to get 1 equal to dy dx out. then we get 1 plus cos y. Okay, which implies that our dy dx is equal to 1 over 1 plus cos of y. Okay, please, if you find this video helpful, don't forget to subscribe, like, and share. Thank you very much.